Our goal now is to identify in some numerical way which is the straight line that goes through the centers of the vertical strips. And so just to recall one of my rough hand-drawn pictures again, of which I hope you are drawing several and better than me. You've got a given variable x, you're trying to estimate a variable which we're calling y, and your decision is, if I give you x, you are going to go to the strip corresponding to that x, because that's where the point is for your person, and you're going to pick off the center of the strip. And if you do that for a football-shaped scatter diagram across all the strips, you get roughly a straight line. And our goal is to somehow identify what this line is, so that if I give you an x, you can somehow plug into that line and get an estimate for y. And the reason I'm giving you this hand-drawn rough picture is that even with a hand-drawn rough picture with deliberately no variable nor numbers along the horizontal axis, you can see that what this line is has to do roughly with the geometry of this oval. It doesn't depend on the numbers that you are writing on the two axes, in the sense that you might as well have drawn the picture in standard units. And that is exactly what we are going to do next. We're going to draw a picture in standard units, and a word of warning, there's a lot going on in this picture, lots of lines and colors and so on. We'll take it one piece at a time. Here we go. Right, so the picture is in standard units, which means the point of averages is now 0, 0. It's the origin. Along the horizontal axis, you have x in standard units. Along the vertical, you have y in standard units. And we are trying to find the line that we're going to use as our estimates. And a very natural first line to draw is the 45-degree line. That's the line in red. Equal standard units on either side. That is what your text calls the SD line. The same number of SDs away from average on both variables. If I look at this red line and I say, well, I'm given this x and I'm trying to estimate y, then I know that my point is on this blue strip here. This red line is not picking off the center of that blue strip. It is too high. It is the wrong line to use. Which is the line we do want? We want the line that has the center of the strip as the point through which it is passing. And that line, from what you can see, must be flatter than the 45-degree line. It must be flatter than the line whose slope is 1. That's the slope of the 45-degree line. So we're looking for a line that has a slope of less than 1, and the way I've drawn it, the association is positive, so the slope is going to be a number between 0 and 1. And in this game, there is a very famous number between 0 and 1 that is floating around, and has been so for the last section. What is it? Yep, it's the correlation. The estimates are all on your green line, and the slope of the green line is the correlation. In fact, that is one of the ways in which the correlation was identified as being very important in this problem. So the slope of the green line is a fraction, and that fraction is called r. And what this does is that it allows us to create an equation. What we're learning is that our estimate, at least in standard units, is going to be r times the given x in standard units. Why is that? Well, this line is passing through the origin. It's a natural idea that any line of estimates should pass through the point of averages. So the line is passing through the origin. It has no intercept. So all it has is a slope. And what's the slope? The slope is r. And so what's the equation? The standard units form of our equation is you take the given x in standard units, you multiply by r, and that's your estimate. in standard units. So this is called the equation of the regression line. Why regression I will discuss in some detail in a later segment. For now, the regression line is the line we are going to use to create our estimates. And what is its equation, at least in standard units form? The estimate that we're looking for in standard units is the correlation times what we're given in standard units. And since what we're given is typically on a different scale than what we're trying to estimate, I have been careful in saying given x in standard units of x, and then estimate of y in standard units of y. The use of this equation, that is the numerical method for finding your estimate given a value of x, is easily accomplished by following the steps that the equation asks us to take. So here are some data. You've got a distribution of heights, you know the average and the SD. You've got also a distribution of weights, and you know the average and SD of the weights. And now here is the number r that connects the two variables. And you are told that the scatter diagram is roughly football shaped. So what are you asked to do? Well, you're given somebody's height. You're told that this person is 73 inches tall, and you are asked to estimate the person's weight. Well, that's exactly what we have been trying to do. I'll give you x, you tell me y. You won't be able to tell me y exactly, but you'll be able to give me an estimate. So what does the equation say to do? We read it from right to left again. Start with your given x in standard units. So x, what are you given here? You're given the height, so that's x, is 73 inches. So take your 73 inches, convert to standard units, which you know how to do. 73, take away the mean, divide by the SD. 73 is 6 inches away from average, which is 2 standard units. Right? Now multiply that by r. You have 1.2 and you're done. That is your estimate, the 1.2. With the slight problem that it happens to be in standard units. You don't want standard units, you want pounds. So what do you do? Exactly, you convert the standard units to pounds, which you've known how to do for some time. So the estimate of weight in pounds is 1.2 SDs above average, and you're done. 184 pounds is your regression estimate of weight based on a height of 73 inches. Recap of the moves. Work in standard units. Take what you're given, find it in standard units. You knew how to do that some time ago. And the next move, this middle move, is the regression move. Multiply the standard units by r. And that's your answer. But now convert it to the units that you want. So notice that regression has happened just here in the middle move in a very simple way. You see how many SDs above average you are on one variable, and your prediction is that times the correlation. All the rest is unit conversion. And so if you felt that the unit conversion stuff was a little dry, I don't blame you, but this is what it was for. What we're going to do next is another numerical application which looks rather different from this, but in fact follows the same moves. And what I'm going to give you is that the midterm and final scores in a class have a correlation of 0.5, positive, not surprising, and the scatter diagram is roughly football shaped. And you know what? I'm not going to give you anything more. I'm not going to give you averages, and I'm not going to give you SDs. And I'm going to ask you to make an estimate. One of the students is on the 80th percentile of midterm scores. Estimate the student's percentile rank on the final. Can we do this? Do I have enough information? What have I got? I've only got a correlation. I don't have averages. I don't have SDs. And I'm asked to make an estimate? How am I going to do that? Well, what am I given? Am I given a midterm score? No, I'm not. I'm given a percentile rank. What does my method say to do? It says, take what you're given and find it in standard units. How do I find this in standard units? It's not a midterm score. I don't have an average. I don't have an SD. What have I got going for me? I have a football shaped. And we said that if the scatter diagram is football shaped, then you can assume that each of the variables is approximately normal. And so now I am looking at the 80th percentile of a normal distribution, and I need that in standard units. Where do I find that? Exactly on your applet of the standard normal curve. The z on the horizontal axis, those are standard units. So that applet is another way of finding standard units if you know your distribution is normal. And so what should we do? We're going to use the normal curve, and we're going to find our given x in standard units. The given x is the 80th percentile, and so we are going to find the 80th percentile of the standard normal curve. You are going to find the z so that all the area to the left of z is 80%. And if you do that, you get 0.842. 0.84, something like that, close enough from the applet. So the midterm score in standard units is 0.842. Now you have the regression move. Take that and multiply by r. What is r? r is 0.5. So 0.5 times 0.842 is 0.421. And what is that? That's my answer. That's my predicted final exam score, but it's in standard units. And if I had been asked for standard units, I would be done and I would go home. Except I'm not. I'm asked for the percentile rank. So I need to figure out what percentile this is. In other words, I need to figure out what percent of students scored less than this in standard units. So in terms of areas under the curve, that's all the area to the left of 0.421 under the standard curve. And my applet says that's 66.31%. And that is the answer that I'm looking for. 0.421 standard units is my estimate. That has 66% of the area to the left of it, so the corresponding percentile rank is roughly the 66th percentile. So to recap that, the regression method says, take what you got and convert to standard units. Fine, I have the 80th percentile of a normal curve. I'll convert it to standard units by simply looking it up on the applet. Next comes the regression move, take that and multiply by r. That's your answer. Almost. You need to put it in the right units. So the last move is find what percentile corresponds to 0.421 standard units. And that happens to be the 66th percentile. Notice something here. This person started out on the 80th percentile of the midterm scores. And what is your estimate for the final? 66th. A little bit lower. It's not 80th. If you recall, the 45-degree line, the equal standard units line, was too steep. So starting at the 80th percentile of midterm, you will not estimate the 80th percentile on the final. You will estimate a little bit lower. How much lower depends on the correlation. In this case, with a correlation of a half, we're estimating 66th percentile. That's worth remembering, and we're going to come back to this idea. If you are starting out above average on one of the variables, and your correlation is positive, then you are going to estimate above average on the other, but not quite as far as you started out. So before we go on to examining that in some detail, let's quickly recap what the regression method is. What is it for? It is to estimate y given x. In other words, it's to estimate one variable given the value of another. There are three moves. You take what you've got and you convert it to standard units. We work in standard units. The estimate that you're looking for is that number multiplied by r. But at this stage, your estimate is in standard units. So, at the final step, convert those standard units to the units that are desired.